Hello, everybody. So got a few things to go over this evening. One that I'd hoped to start into last week, and that has to do with object-oriented programming, getting into classes. Still a little bit more to talk about there. So the lab was pushed back, like it still says it's due at midnight tonight, but since we haven't talked about it in class till this evening, here in a few minutes, there's still a little bit more time on that. But I also realized that I meant to copy and paste something that I halfway copied and pasted it. I got it over into our course shell, but I never actually put it in the assignment to replace that small one that barely did anything with the object oriented, the class notation. Those who already did that noticed there wasn't really much there. So I had something else that I've started doing in mind. I might make it just an extra credit assignment in this week's assignment, something. But just a quick example on classes, which is the second example. And yeah, I'll probably just make it extra credit this week. A few points of credit because I meant to copy and paste it to replace the assignment that was in the statewide course shell. I didn't think that was much of an example. Or really what it was, I wanted you to think a little bit harder. So I just realized that a few minutes ago, so it's not in my notes. It's fresh on my mind. Let me point at this real quick. If I go into the course. And I hadn't pasted it into the actual assignment because I was waiting to see who was in the class so I could make little modifications to it. I know Nolan's seen this assignment before. Same one I gave in Java about classes. But yeah, I got this stuff halfway moved over. What it is I was going to ask you to design your own data classes because that one about the vehicle, something that you know very well. So this is all based off people that were in the Java class in the fall. But I was going to change that bulleted list to match some of y'all's interest and put that in the assignment. But something that you're familiar with, right? Like a fishing pole might be a good example, right? There's certain qualities of it, certain data fields that we would need, certain properties of it, but there's also certain behaviors, which would be the methods. So something that you're very familiar with, fishing pole, guitar, custom gaming computer build, things like that. So little things like that, something you're very familiar with, make that data class instead of that generic one that was in the statewide course shell. I mean to customize that bulleted list for you all's interest. That's the people from last fall that I knew something about, and then copy and paste that into the instructions before we got there, and I forgot to do that, and some people have already submitted it. So I'll probably make this one an extra credit assignment this week. So it's basically about like the one last week where you just design the class and then throw out some create a couple instances, throw out some print statements, run a method or two to show that it works. But something that you personally know very well from the physical world. So like game objects are definitely not on that list. Because that's something that's only in the virtual world. But something that you know in the physical world, how would you represent that virtually? If it helps, think about a retail site. What data, what properties and behaviors would you need for an item on a retail site like a guitar? What sort of properties would be important to put in the database or on the website to sell something like that? So something you know well, and I meant to copy and paste and replace the actual assignment with that. And I got it halfway into our course shell. While we're over here talking about changes in assignments, did you all see the announcement this morning? So it's only a half change because really what it is it gives an option.
For module 4, Chris, for the announcement for module 4.
Yes. So we're going to look at APIs this week. And the statewide standardized course shell for this, the new one, uses Flask API. So that's what I prepare the lecture notes for and everything, and what I practice ahead of time. I think we talked about that before. That's why I always have extra computers sitting in front of me where I practiced it ahead of time so we don't get those silly typos or little mistakes in logic and waste all our class time because that's short. We will do that once so that y'all can see that even after many, many years and years and years of programming, that still happens. It doesn't usually go as smooth as it looks in the lecture because I practice this ahead of time. So I want to do that at least once, but not more than once because that does kind of waste the very short amount of time we have in class. But that's what I prepared for to go over Flask. But personally, I prefer Fast API. And I just stumbled across one the other day that happened to be about just within a minute or two of length of that one that was in the statewide course shell. It has the API module that I prefer in Python. It was like, well, I'll throw it in there and give you a choice. They do basically the same thing. It's like a slight difference in example, which neither one of them, and then you're going to change that slightly. Like one of them, the Flask one, talks about drinks. So it has different types of sodas and a description and a database full of that. Our example, those who have had me in class before will recognize it's going to be a bunch of people with a name, age, and town they live in. My fallback class example, we're going to see a whole bunch of those tonight. That's going to be one of our data classes we make tonight. So that we can do that in there. And your homework is to change it up and use it to a book. So a small database and transferring that as an API. And you can choose one or the other. The statewide course shell had Flask. It's very popular. Flask is a framework. So it's a big, huge thing like what Django is. It's actually an alternative to Django. When we get to Python Anywhere to actually host our Django projects, that's one of the options. We can create a Django project or a Flask project. So it's a framework, but they have a nicer API set up than Django does. The Fast API uses almost the same thing. Really, the only difference is when we need to pass parameters into a URL. And Flask, we use angle brackets to pass parameters, and Fast API, we use curly braces. But they go in the same spot. We're still typing in Python code. They're almost identical. They're about an hour each. So if time allows, I would recommend looking at both and seeing which one you like better, or if you have any sort of preference to it. There's a couple things in the videos, especially the Flask one, that I just don't agree with. He said the way he says things. Both of them give what I think is a misrepresentation of why JSON is the most used way to transfer data. The reason we do that is because JavaScript is an international standard for websites, right? So most of the data we're transferring is going to a website where it's going to be processed with JavaScript. So it just makes sense to send it in JavaScript format so it's going to be processed that way. And they just both, I think the Flask API video, he says, he refers to it as just a text file. It's not a text file, it is JavaScript. We send it to already in the format of the language we know is going to be processed, and it to save a couple milliseconds later. The other one, he's talked a little bit more about it, but the biggest reason that we would choose how we transfer it is how it's going to be processed on the other side. It's like JavaScript is an international standard. So we know if it's a website, it should be running JavaScript. So it makes sense to send something in JavaScript format. And the big thing there is JavaScript, like Python, is an open type language. We don't have to worry about type. If we were to send JSON notation to something that's going to be processed in C++ or C# or Java, it would slow down the whole process, sometimes even noticeably. So neither one of those videos did a good job on when we choose how we're going to send our data. But the main choice between JSON or XML, it's mostly JSON because we mostly work with open type languages. But you would make that choice. One of the primary considerations in that choice would be, are you going to process it with an open type language or a strictly type language on the other side? Because if you're typing with a strictly typed language, you should probably send XML. Otherwise, issues can arise. And until your data set gets huge, like the one NASDAQ sends out every 10 seconds, it's probably not going to make much of a difference, right? When say we're wasting time and stuff for, especially in like classroom examples, we're talking about 10 millisecond difference. But if you're doing something like, well, the RSS feed that NASDAQ sends out every 10 seconds, that's a lot of data, and it's going to be more than a few milliseconds. That's something where it could hit the time scale where it would affect people's profit and loss. Because if they're a second off, if they're a split second off on hitting that sale button, they're at a different price already. So those things do make a difference. We use JSON mostly because we use mostly open type languages. And both of the guys in those videos, I didn't think said it right. Also, both of those videos, I watched at double speed and was typing along with it. So you can, I've seen both of them before. So you can increase the speed and use the pause button. So then it's only like a half-hour video. But neither one's going so quick that you can't speed it up and follow along still. But you can choose which one you want to use. Personally, I prefer Fast API, and I prepared the lecture already to go with Flask. So we'll see Flask in class. So you can see the other one there. And then they're almost identical. So you just choose one of them and throw the assignment together. Or if time allows, check them both out. They can be quite useful. Let's see. I think that was all I had to say about that one. I just realized I just come across the other video the other day. It was a guy I'd seen before, and he does really, he does a really good job explaining stuff, very thorough. And I was like, oh, Fast API, I like that better than the one I was going to assign in class. So why don't we want to add that in there as an option? But the difference between them is almost entirely background. As far as typing it, they're pretty much identical when you type it. I mentioned the main difference you'll encounter, which is when you pass parameters through the API. In Flask, you use angle brackets, and in Fast API, you use curly braces. But you put them in the same spot. So it's, from the typing perspective, they're pretty much identical. So otherwise, going to look at classes and stuff about classes tonight, in particular abstraction, because you wouldn't have seen that before. Looked like most of y'all were able to do that lab already from the stuff in the previous class. So we need to take that a step further and look at abstraction and talk about interfaces, because remember, this is a software development class using Python, and we don't have interfaces in Python. Well, we have application programming interfaces, APIs, but we don't have object-oriented interfaces like we would in the C family of languages. But you might see those at some point, so we at least want to talk about them. And then get into persistent data, which is going to go quick. We're going to breeze right through the ones you would have seen in the SA 140 class. The sequential text files, probably want to look at that. That's what textbooks always show. Just keep track of what order you write the variables to the file in, one data point per line, and then read them back in the same order. The simplest way of storing data. So we might skip right over that and jump into, I really want to look at JSON, XML, and CSV. That's the big ways we would transfer data. And again, really it comes down to personal choice. If a human's reading it, if a human's not going to read it, it doesn't really make much difference. Those are human readable and good formats for a machine. But we want to consider what language is going to be processed with on the other side. If it's going to an open type language, JSON's better. If it's going to a strictly typed language, XML will be better, because XML includes the type, what type of data it is. But that is quicker as far as CPU speeds, not human time scales. Then a couple other things.
Chris, I'm sorry, you said which one is quicker? JSON because of the JavaScript, most of them using JavaScript, you said?
Depending on where we're going. JSON, most of the time that we transfer data across the internet, it's going to go into a web page to be viewed. If we're going across the internet, which means it will probably be processed with JavaScript. So if we send it in JSON, that'll be fine. So, or if we know it's going to be processed with Python on the other side, that's also an open type language. So JSON would be better for that. But if we know it's going to be processed with C# on the other side, we lose a whole lot of, there's a whole lot of resources wasted, and the time grows exponentially as the computer has to figure out what type of data it is. If we send the number 3, it can't just work with the number 3. It has to know it's an integer. And it takes a lot for a computer to figure out that it's an integer. One of the reasons that Python's so slow compared to other languages. So
Translation.
yeah, it's, if you know where it's being processed on the other side, then it makes a difference. If you don't know where how it's going to be processed on the other side, it's purely personal preference. Like, yeah, I'd rather type in JSON than XML. But usually we don't type, we only type the data. So we don't type the curly braces and colons for JSON, and we don't type the tags for the XML. So the part we're typing is the same either way. The computer is typing all those tags, or should be. It's a very tedious, repetitive, easily predictable thing. So the thing machines are perfectly suited to do. Yeah, and if we're typing, if the machine's doing it, then it doesn't make any difference whatsoever. And we'll see that persistent data this evening. So there's another point I'm going to look at about transfers between those big 3 that I was going to say. So I guess we'll start with some basic object notation. What would be review from what you saw in the previous class, hopefully.
Yeah, I'm gonna need to pay extra attention to this one. I have been beating my head against the wall for the last 3 hours about the class project. And it's because I wasn't able to attend last class.
Oh, we ran out of time last time, so it's not, it doesn't get pushed back, Kyle. So you can have a little bit more time on that one. It's not necessarily due at midnight tonight.
That's great. I'm still, like I said, I've been beating my head against it for the last 3 hours, which is generally how I learn really well. So I expect by the end of this, me and classes are going to be best friends, but right now, mortal enemies.
Okay, so a few notes. First off, one of the very important things that a lot of people get confused at first is they'll try to think of classes as something like a function, but they are very, very different than that. Or they'll try to think of it as some of the complicated processing that we're doing. But a class is we're designing a data type. So it's like an integer or a Boolean. It's not a bunch of instructions. It's a template for something. Some of our terminology, so our technical term, when we set up I'll start by saying variables. There are subclasses of variables. Variables have lots of subclasses, but in object-oriented programming, the variables inside the object are called data fields. And you may have heard that somewhere else, in particular in a class on relational databases. Everybody has the like DBMS 110 class, SQL class? That's good because we're going to look at SQL tonight. Or a SQL and Python code. Because you all may have seen what's a good one? This one I'm pretty sure you've seen, from tkinter, import, everything. Right, a lot of y'all have probably typed that instruction before. That looks an awful lot like a SQL query. It's not a coincidence. It's the exact opposite of a SQL query. It's the exact opposite of a coincidence that certain Python instructions look an awful lot like SQL queries. And when we create objects, design classes, so a class is the blueprint, that's a design, and the object is an instance of it. So subdivision, American subdivision, we have 50 2-bedroom ranch homes, right? 2-bedroom ranch homes with a garage and a basement. That makes up a subdivision, and they're all built off the same blueprint, the basic design of what a ranch home is. But each one is unique. So that's an instance or an object. The actual house that is built from that design is the object, whereas the class would be 2-bedroom ranch home. So we're setting that up, types of data. And we use the term data fields to store our properties. Let me draw the donut picture on the board.
So what would the subdivision itself be classified as?
That doesn't fit nicely into that analogy.
Okay.
But I guess we could think of it as a database. Yeah.
Okay, okay. Oh, okay, yeah, that does make sense. Okay. Yeah, and the database is holding the different homes,
Yes.
different types of bedroom homes. Okay.
So in our relational databases, we have those nice little tables.
Mhm.
We have records. Each cell is called data field. And we build that all up into the table. Well, a record, a data point and a record uses the same terminology as a data point in object-oriented programming. Looks very different in the text file. But everybody's aware that the text file is not what passes through the CPU, right? So I'm going to iterate that again. They have the same name. They look very different in a text file, but the text file is not what goes through the CPU. An object would be like the row in the database. Only we take it further, it's not just, those are just data points. We can include functions, behaviors. That's why I like the donut picture.
Sorry.
So an inner circle with properties and an outer circle with behaviors. So what, for a vehicle thing, what color is it? Whereas a behavior is speed up, slow down. And those are the two things we mostly need to virtually represent anything and build a new data type. So think about that. What properties does it have? That's attributes or data fields, and behaviors are methods, which methods and functions, when we're talking, are interchangeable. When we're answering questions on a multiple choice quiz, they're not interchangeable. Methods go with object-oriented programming and functions go with procedural programming. But when we're talking to other programmers, we're going to use them interchangeably, whichever one fits better in sense. But think about this circle of representing things. And
So Chris, that in the circle in the middle, you can have as many attributes. You said like blue, okay. And then you can have as many.
Yeah, but it wouldn't necessarily be blue. Blue belongs to the instance.
Mhm.
The property would be color.
Okay. So
then
where would the instance be? Because I know the behaviors below that.
Oh, then an instance is what we create out of it. So in
Okay.
here, car. So for like a car one, in our inner circle, we'll have things like color, doors, make, model, all of that stuff.
About the car.
All of those things. And then our behaviors, we could like speed up, slow down, turn. I'll put parentheses on them. So they're methods. And then an instance is when we would have, so this was the class. And the car instance or the object, we would have that's where we would have blue, two-door, Firebird.
That's like a template of
So that's the instance is where we get the details.
specific, okay.
Another instance or object would be a green four-door Camry. That's not make, that's model.
So the instance in our homework assignment would be like the output, quote unquote, whatever.
Yes. So the instance is when we make something out of that design. Because it's going to be used repeatedly, right? My general one in class that we'll get to later when we make things is my classroom data example is always people. Just make up some names, so name, age, and the town they live in. And so the class has those properties, name, age, town, maybe a function or two, usually made up on the spot, depending on what the class is doing. And then the object would get stuff to fill those data fields. We would assign the value to each of those data. But all of those separate data types, the individual integers or strings, or other objects that we might have created, those simpler data types get combined into a more complex data type, so it can handle more data for us. Or erase a picture, if you think about it like connected to relational databases, and the objects like the row starts as a row in a database, and then we add some methods on at the end. We build up more and more properties to get a more complex data table, a more complex representation of what's stored in that database. But there's a lot of connections that look very different in text files than what they do than what they do when they actually pass through the CPU. So we have some keywords. Let me make some notes here. We need to do that. Object-oriented programming, example 1. Run a markdown cell, so we get a nice little label there. So we're back to some code. So our keyword for creating a design, we've already used it a couple times, is class. We're going to create a new class of data, something brand new. I'm going to use the one we were writing the other day on the board, right? Does everybody remember that? We had an animal class. The rough representation was, rough idea was for a veterinary clinic. What would be needed to virtually represent the patients coming to see that vet? So we'll have some class called animal, and there are certain things about it that we know. And again, the general Python syntax, right? Keyword, something unique to our situation, a colon, then we indent stuff. And there's one method we always need to start off with. Define underscore init, short for initialization, but it might just be init. And the first parameter of every single method we put in here is passed here from the Python interpreter, or wherever we're running the Python code. We have different alternatives, but the Python interpreter passes in the first parameter. So we have to make a spot for the one we know is going to come in that we'll never actually address in our own. And that's, we use the word self. And figure out one of these markers. You can still see the video on the board. When we assign that, we'd say like X equals a new car and pass in all those attributes to fill those data fields. Then X is the instance of the car. So X is what fills that self parameter. And it shows up, seems to show up in two different orders when we write our code versus when we ask for them. There's a slight change there, but we'll get to that here I'm thinking about 15 minutes, 10 minutes, very, very soon. And then we need some properties. So what did we say an animal had? It had a name, an age, and a weight. Name, age, weight. Yeah, I'll do it this way. And then we can assign those. In the previous class, you probably saw with the double underscores there. Self dot underscore underscore name. Did everybody see that in your STEM 140 class? That's semi-static. Static means there's one and only one copy. Usually that means we can look at the class, the blueprint, the design, instead of going to a particular instance. But in Python, we don't have private data like we do in some of our other languages. So that's most often used as an indication by the programmers that you intended that to be private data, but you're typing in Python, so we don't have private. But we're just going to skip that and leave it immediately accessible. Because it's not private, we can still get to it. So to get to that, if our instance was X, we'd say X dot underscore animal underscore underscore name. And then we can still access it. So it's not private. But if we want to treat it like it's private, we would do that. Here we just say self.name, then the Python interpreter passes in X. So anywhere in our code, we write X.name and we get right to that value. And then just assign what was passed in as a parameter to fill that field. Because here it's only for this local function. We need to set it to the entire object, and that's what the self does. It connects it to the animal itself, not just one of the methods in the animal. Self.age is age. Self.weight is weight. I'm going to add sound in here. Sound equals roar. That seems like a good default sound for an animal.
Yeah, I like that.
And notice how I did go ahead and assign that one. So we don't have to pass in the sound. That's optional. But name, age, and weight, we didn't put a default value in those. So those have to be put in. The optional ones go at the end. So
Okay, I'm sorry. You said so the optional values go at the end.
so
What else makes it optional? Is it that you made it a literal or?
Oh, yeah, because I already assigned something there.
Okay,
It's a literal in this case, but it doesn't necessarily have to be a literal. But there is a default value for sound. There is no default value for name, age, and weight. So that makes it optional. When we ask for it, we don't have to fill in that parameter because there's already something there.
already there. Okay.
So those have to go at the end.
And you can have as many as you want as long as they have an assigned value.
Yes.
Okay.
And then we have ways to access all those. We can set up methods. I mostly added that sound parameter in just to make a little method here.
But you can't have two sounds though, can you?
I'm going to go with no.
Okay, I didn't think so.
We could make sound a list, and then we'd have a.
Okay.
But I don't think that's what you were asking.
But it makes sense that you can, okay, I get it.
Yeah, we have lots of control, but identical redundancy would only confuse you. The computer could tell them apart, but in the text file they look the same, so you're the one that would be confused. So even when that's possible, we would probably still want to avoid it. So to make a function, notice it's still indented inside of the class. We'll define a function. I'll call it make sound, just so this does something. And I want a function that doesn't take in any parameters. But the Python interpreter is going to send a parameter. Because to call this, we would type, well, if it's X, we type X.make sound. So we need a place for that X to go. And it actually goes in here. So the very first parameter in every single function, every single method has to be self. And then when we ask for it, like later in our code, it comes out this way when we have an instance. That self moves out front. And it wouldn't be self, it'd be like X, or in the case of animals, it'd be like Fluffy or Simba or whatever we called the particular instance of the animal. But when we're making the method, it needs to go in as a parameter. And then we just return. So I'll return a format string and say, let's say maybe self dot name goes self dot sound, just to get that sound into a sentence. So with line example, like Simba goes roar, it's simple. Just have a function there. I was mostly wanting to look at that one. Hopefully this is at least partially review from previous class. Might need some other things, like when are two animal objects equal? Or asked that question last week, right? That's a difficult question to ask. It's going to be different, but we know we're going to want that in our code. There's a method that we inherited. There's a top, if we use parent-child terminology, there's like a grandparent object, and it is called object that everything inherits from. And it has certain things. One of those being equal, EQ, double underscores before and after it, takes in the self parameter. And this one also needs an other parameter. And this is the method that gets called when you type equals equals. So like if, I don't know, if we look at weight, a large cat and a small dog might weigh the same. So if Fluffy equal Fido, we want to make that comparison between our data types. So that calls this. There's also an LT for less than, GT for greater than, LE for less or equal, GE. They're all almost identical, but we have to define what it means for our object to be equal or smaller or greater than another. Well, first off, we probably only want to do that if it's another animal, right? Trying to compare it to an integer wouldn't make any sense. Let's say weight. Weight sounds like a good equal. We're looking for a vet's office. Was when we were talking about when we started talking about an animal class. So last week. So as far as equal, we want to know what size kennel to put them in. People often say the word cage, but the dogs, we should say den, because it's a nice safe spot. Dogs, it's humans that don't like that sort of environment. Dogs feel very safe there. So we need to compare them, but we don't. Only other animal type of data would have that weight data field. So we need to make sure it's that first. So like if is instance other, have y'all seen that method before? Is instance, so that's saying is the other thing an instance of something. Is instance Python. I was looking for the actual documentation. So again, with the point I like to express, especially at first, the official documentation is going to be confusing. Tutorials are going to be much easier to read, but they're going to be abbreviated. They're just going to cover that basic introduction to it. The actual documentation is the full user manual. So always look at the official documentation first. Is there not an instance right there? Yeah, always look at the official documentation first. And Then go look at the tutorial and use the tutorial to learn to read the user manual. Because there's a lot of things there's not going to be tutorials about, but the same person wrote that Python documentation. So if you use the tutorial properly and learn to read the user manual, you won't get stuck later because there's not a tutorial for the thing you need. Or learn to use the user manual, not just learn to write that one line of code from the document that you see in the tutorial. Return true if it's the same thing. So what object are we looking at, and what type of class do we want to know if it is? And it's going to return true or false. So
we're only looking for not all of those attributes, just or not all of the attributes in that class, just one, and you're looking at the weight right now, right?
that's what I was thinking, to keep this simple. There might be other things, but every situation is going to be unique, right? So this is something we need to define every single time.
Okay.
The default version, the one we inherited from Python master object, if that's one way to think about it, the very top level Python super object, often like the parent-child terminology, and call it the grandparent object, the one everything else automatically inherits from, it will only return true if it's stored at the same spot in memory. Because Python has great memory management, so if we already have a 3 in our code and we go to store 3 somewhere else, it's just going to use the one it already has stored. So that's why they're equal, because they're stored at the exact same spot in RAM. That's
I
probably
recommend doing them all separately, so that because if it's equal, one little teeny tiny little thing can be different, otherwise it's false.
yes. So we want to define that exactly, and same thing for greater or less than. What's smaller? Define greater or less than, the computer subtracts, right? We have the binary representation. We subtract. If there's all zeros, that means they're equal. If we have a positive number, that means the first one was bigger. If we have a negative number, the first one was smaller. Is how that works internally. But we need to define what it means as far as the text that we're writing. Because knowing what the CPU does doesn't necessarily help us decide which one's smaller or bigger if we're talking about animals. If we're talking about animals, the weight would be smaller or bigger. That's why I went with this here. So, okay, if they're equal, if they're the same weight, we'll say that's equal. Go with the smaller or bigger words for the animal. If self.weight is equal to other.weight, and those are both animal class, so they'll both will be able to access that weight attribute from both, then we can return true.
Okay.
Otherwise, we're going to return false.
Does other have to be defined, or is it already defined somewhere? Other.
Oh, we passed in as a parameter.
Okay.
Call it anything. Animal would probably be better there. I'll call it anim. So the instance, the actual other instance we want to compare to, compared to our own weight. And that will allow us to use equal when we compare them. Right? If we have a cat data that we stored to the variable named Fluffy, reference value Fluffy, or a dog data.
So on if self.weight equals other.weight, does that need to be anim.weight or?
Oh, yes, it does.
Okay, just making sure.
And there's a few like that. You will see lists of them. You can look up the list. STR. This is the toString method. Right, when we say print and we're concatenating together a big string and we have an integer and we type str to wrap around that variable name to turn it into a string, it automatically calls this method. But there's also a better one we can call. There's also a representation. So that is explicitly a string, just explicitly going to text. We also have, where's my cursor? REPR, which is representation. Oh, my colors disappeared.
So is the difference in that something that can be concatenated maybe? Like on a string, you can concatenate? Because I'm trying to understand what the difference in a string and a representation is.
I was getting into that.
I'm sorry.
Representation can take the place of a string, but string can't take the place of a representation.
Okay.
Make a big difference on GUIs if you get into character, something we haven't seen yet. I was getting ready to talk about a type of data and colors. You might want to include that in your representation of it somewhere. Different things like that. But if you do not override the string method and do have a representation method, then when you call that two-string casting method, it will use the representation method. But if you have both of them, it will go to the two-string, the SDR method. It's generally considered better to use the representation. I don't know why all the colors disappeared. It was color coded just a moment ago, wasn't it?
Yes. Yes, it was, because I was wondering about that. You had something up top that I hadn't seen before, a reserved word. It started with a G. Oh, goes. Yeah, goes was purple or something.
Hey, I'm not sure where the colors went. They'll probably come back in a moment. But it don't really need the colors. Those are just to help us spot typos is the big thing there. If the lexing doesn't kick in, then we might have typed the word wrong. What the word is the part that matters. So we need to return a string of this. So I'll return a formatted string. Say like self.name is a self.age years old and we're in that weighs self.weight pounds, I guess. We're Americans, call it pounds, still kilograms. I'm sure a vet would call it kilograms. And goes self.sound. So it's still a string version of it. But whenever, if we don't have a string method, it will call this, and there are other things that can use this. So it's generally better to use this. I tend to use the string method. I just thought I'd show that since you probably didn't see that in the previous class. We have both of them. Where have I used? There's one place I always use representation. Oh, I do that in Blender. I use representation a lot when making buttons in Blender, or because it's not necessarily going to a string. So representation of a 3D model for a game transferred into Python code. I wouldn't want the symbol 137. I'd want the number 137. And you get that from the representation, but not from the string. If that helps to clear up the difference. If that was confusing, just think of it as two methods that'll give us back a string. Yeah, that's probably good for now. Basic Python syntax. Does that make sense? What all was going on with that? So just kind of ring a bell, because I have some other stuff I want to look at with those afterwards. And now we can create some instances of it. Or we can create a child of it, more specifically. So we could say, let's do a class for a child first. Dog might be one type of animal. And to inherit all of that stuff, it's going to be some sort of, the parent goes in here. So it's going to inherit all of this stuff that we already defined. Do you all remember the open close principle last week? open for extension, closed for modification. Animal is now closed. It's sealed up. We sealed up that capsule. So if we need to make changes, like some of the animals, a dog per se might wear a bandana. We need another data field to define whether or not that dog wears a bandana.
Mm.
We
Is
can-
that because other things are dependent on what's already been closed?
That was just one way to say it, but everything else is going to be the same, right? We want all of that stuff we just defined for an animal, so we don't want to type it again.
Mhm.
We want to get it from there. So this is gonna probably look a little bit different than what you saw in the previous class if you saw the inheritance in your 140 class. And our first parameter always needs to be self. And we're gonna add this new Boolean called bandana. But there's a whole bunch of stuff up here that we might need. So we need to get that. If you want to type it all out, it needs to go in the same order it was in the parent. You'd have to do name, age, weight, sound, do sound again, and then put the new one at the end. But we can just point to that stuff. We saw args and quargs, right?
Yes.
Arguments are the single values, and keyword arguments are the lists and collections of values. But really, it's a pointer. That's what he used. He used those two terms when he created Python. Like anytime we put a variable there, we can make it up. Most people just stick with args and quargs. What matters is the 1 asterisk or the 2 asterisks. However that word is said. But that's what's known as pointers, which we don't really do anything with Python in pointers, except for a couple that are remnants from other languages when it was created, like the args and quarks. Then we can pass that right back up there. This is inheritance. And the way I like to think about this is dog is a child of animal. And just same way we use that word inheritance, it's going to inherit all that stuff. But as a child, there's more access to the parent stuff, right? You have more access to stuff in your parents' house than the people down the street have access to your parents' house, right? The child. So same thing with the classes. The child class has more access to the parent than we do from the outside. One of those things is we can reach in and access those double underscore methods, like the init. So we can just call super. Notice that change colors as a keyword. So we're back to color changing. Super dot underscore underscore init underscore underscore, and we can directly access the parents init method. And in this case,
This is the super class we're talking. And then this is the super class, right?
this only goes up 1 level. So up 1 level, this animal is a super class of dog. There's a super class way up at the top that everything inherits from. So eventually we'll get back to that. But it only goes up 1 level.
Mm.
It only goes up to what's in parentheses here, the one we inherit from. Why is that? It's really weird. It only goes up that far. So we'll pass all of that stuff up and then run all the stuff in this constructor, and then make the changes needed for that dog object. So like self.bandana is going to be either true or false for yes, it wears a bandana, or no, it doesn't wear a bandana. And the animal object has that generic thing. Roar doesn't sound very correct for a dog. Sounds like the good catch-all for animals in general. But if our dog's going roar, then something's very, very wrong with it. So we might want to override that sound, change the default value, something more appropriate for a dog. There's bandana. So then we can make more methods that weren't in the parent object. So like if bandana, because that's going to be a Boolean. If bandana, then return if string says self.name does wear a bandana. Otherwise, or else return string that says don't put a bandana on self.name. Why do you give me two parentheses that time? And then we can run that class and check for typos. Animals. Oh, that's where I must have bumped that button. Not marked down. It should be code.
Oh.
It's Python code. So when we run this one, run the animal class, missed a colon somewhere. There it is. Put that in there. Try running that again. Okay, no error messages, but ended up with way too many things, so I probably shouldn't have done all that once. Now if I run that, okay, no error messages. So now we have animals and dogs defined, and we can create an instance of it. So
Awesome.
I'll do a cat too. Let me go ahead and do that. I'll put it here. Class cat, and here it's from animal. And we aren't going to do anything special about cats. Right? They're finicky. They cats come the way they want to come, and that's about all we have with them. So we'll just make it directly like the parent object. Grab all our arguments and keyword arguments. Pass those up to the super
You make
object.
the sound meow.
That's what I was going to change.
Okay.
Pass those args and quargs right back up to wherever they need to go. And then self.sound equals meow. And that's the only thing we need to change with the cat, right? Everything else about the cat is the basic animal.
Yeah, they don't like bandanas.
Yeah. Cats aren't domesticated. Cats just came into our house and we never kicked them out. They sometimes refer to it as self-domesticated, but cats go back to the wild very, very quickly. Whereas other domesticated animals aren't going back to the wild. They get lost in the wild and probably aren't going to survive long. But cats are still wild animals. They just moved in our houses and we never kicked them out. Now we can create some instances of it. So this is where, so those are the design, the blueprint, what we want our object to look like. Make a Fido object, which would be a new dog. And then we need those things. So his name is Fido, is it's kind of ambiguous what order we send those in, isn't it? Looks like bandana's first, but on the parent one, the name was first. So we can also, when it's ambiguous, there's a way to figure it out, but I'm just going to go with this because this is a better way. We can also put the parameter name there and make sure we're assigning the correct one to the correct value. So make sure that Fido goes in the name. Age is 4. Weight is I don't know, 22. What's that, bandana? Bandana is true. Whereas Fluffy is a cat object. Name's Fluffy. age. And in general, I would recommend go ahead and do this. It's just a little bit extra typing, but it really helps to protect from issues happening. From years of experience, it seems like that about half the time, if I don't do this, I end up having to come back and do it to fix bugs. So it's better just to do it, just a little bit extra typing, keep it straight. Age is age.
Is that user input too, by the way? Because I can't begin to, I mean, that most of that information would change. So like if someone were at a vet office and then Fido came in and then, that information changed.
You have to set up a way to change it.
Okay.
But for right now, we have to have some starting values to create it.
Okay.
But yeah, that's jumping way ahead. We'd have to set up a way for it to change. Or start it in, but this wouldn't be done with the user input. The change, I'll make a change here in a second and show you changes.
Wait, so before we ask a user to change it, it already needs to be defined?
Yes, either that or we get the input from the user and define it the first time. We can't create it without something there. So we could get that input from a user and create it the first time. But we can't just create it blank.
But you can just literally name it blank if you wanted to, which is what I was gonna do.
Oh, like Rex equals dog. Oh, in our situation, that would crash. If you left all of these off, if the only parameter you put here is self, then you could make it blank. But if there's things there, we have to fill them in. It doesn't matter where we get that data. For our example, I was just typing it in, but we do have to fill any data fields we set up. Any attributes, any parameters we put in that, the init method is called a constructor. Anything we put in the constructor does have to be filled when we create an instance of it.
Because otherwise we wouldn't have put it in the constructor to begin with because there was no data.
Exactly.
Okay. But it could later on be added. We just would have to do another instance. And then at that point, we would have to go in there and say self, comma, bandana, and then args and quargs.
Oh, no, that wouldn't happen from an instance. These are instances.
Okay. That would be for them another class.
Yeah, we'd have to make another class.
Okay.
So now when I run that, it says it's missing something. What did I miss?
My code that I'm following your code on Spider. It says line 37, if bandana, it says the bandana not defined.
Missing the parentheses in line 16.
I don't have line numbers. So this one, we shouldn't have anything extra. Did I make a typo? I don't see a typo.
Do you need the parentheses right after super?
Yeah, that's what.
Oh, yes. Okay.
Awesome catch. Never said that.
Okay, there we go. And then we can print that stuff out. So if we say print, which, as you all know, will automatically call the toString method and say Fido, it's going to call the representation. We did the representation again, but there's no toString method, so we'll just use that and do that default toString. we could ask for particular things. Down here, we could say fluffy dot weight. So I think if I just run that, yeah, I get a number. So let's say fluffy dot weight, and we can just change it. We can directly access fluffy, the fluffy instance of cat class exists. So we can access that stuff and change it. So let's say fluffy gained a bunch of weight and now weighs 15. So we get that, runs that, and we can check if fluffy is equal to Fido, then this is that equal method. Print. That's a big cat there. Usually cats are smaller than dogs, right? So if they're equal, we want to print that. Here's otherwise everything seems normal. Print. Everything seems normal here. Run that. So everything seems normal, but if we come back and Fluffy gains a bunch of weight because cats just lay around all day and eventually hits 22 pounds. Run that, and now when we hit that, they are equal because they both weigh the same amount. A starting point, it's not your subject we're learning by doing, but does that make sense? So the next thing that I want to talk about real quick,
Yes.
which this, I know the one's gonna take about 45 minutes. Yeah, let's take a break and then we'll talk about something else about with objects, sort of the next step forward. Because we put this method in here. We have a data field that we can use. But what if we did that all in the data field right here? Only with that method. Everything's gonna have a make sound method. But not everything's gonna make the same sound.
Same sound.
That's where we get into abstraction. So that's the next thing I want to talk about, because you want to have seen that, and into interfaces in other languages. We don't have interfaces in Python, but this is software development with Python. So we still need to talk about that, because as software developers, you will see interfaces somewhere. And the code version is really the same as you would have used that in, you've used that in other places. We'll talk about that after a quick break. 10 minutes sound good to everybody? I see big head nods in the class. So my laptop says 7:09, so we'll get back to it at 7:19.
Thanks, Chris.